What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 10 of our data visualization with Python tutorial series, in which we explore the MatPlotLib package. So guys, in this video, what we will be doing is basically controlling a marker's style. So I will comment that down below here. Controlling a marker's style. So you may ask now, what is a marker? So a marker really is referring to the dots themselves, or the representation of the dot themselves. Now the dots I'm referring to are the dots we find, or the data points we find on a scatter plot, and sometimes they may even make themselves present on a line plot and so on. So it's really referring to the data point itself when plotted on certain types of visualization. So essentially what we learn now is how we can adjust the size, the, I would say, shape and orientation of the marker itself. So there are several ways that we can do it, right? But one of the most common ways, and I think probably the only way you'll use, is just to use the predefined markers. So these are markers, or marker, I would say, representations that have been pre-made by the matplotlib developers, and we can use these. Okay, they are often represented as a number, in the range, or within the range 0 to 8, both numbers included. And alternatively, you can just call them, or define them, or use them using their string representations. So I'll just say strings. So let's actually view an example now. What I'd like to do is, suppose we will use a scatter plot. I think that would be the most convenient. So I will proceed to plot two scatter plots. So go ahead, import numpy as np, import matplotlib.pyplot as plt. Next, what I'd like to do is just set up some dummy data. So random dot, let's do standard normal. Within this, I can pass my shape of 100 by 2. And you guys know, when it actually comes to the plotting portions of the code, we'll do a slicing, okay, in which we can use the first and second columns for the x and y values respectively. So let's do a plus equals to numpy.array. Within this, let's say -1 and -1. Next, what I'd like to do is set up another data set. So what we can do is numpy dot random dot, let's do standard normal again. So shape again, let's just do 100 by 2. It's the exact same procedure, guys. We'll do b plus equals to numpy.array. Let's do +1 and +1. Now it's time to scatter these data points. So a simple slicing operation, all rows column 0. This is from the A data set. So let's do here, all rows column 1. Color, let's keep it a standardized black color. Marker, this is where the interesting parameter comes into play. Pay attention to this parameter, guys. So let's do x, right? The lowercase letter x. Now let's do again plt. Let me copy this, and we'll change the A into B. And for the marker, for the second plot, what we can use is I think this is called a caret, but it's that upside down V character. Okay, so what we now can do is plt.show, and upon running the script, I press Control Enter. Cannot interpret one as data type. So what I actually need to do here is add another set of parentheses, I actually forgot to include one more set of parentheses because you guys know the shape or the values themselves, they need to be passed within a tuple. The first parenthesis is for the numpy array function, and the second level of parenthesis is for the argument we pass to that function. Okay, so that's fine. Control enter, and as you guys are going to see, we obtain a plot, and on this plot we can obviously tell that there are two I would say different scatter plots that have been plotted on the same canvas. How do we know this? Because one portion of the data is represented by X markers and the other portion is represented by triangular markers. So that's the effect the marker parameter and argument has on the output visualization. So that's fine. Now, in case you are wondering, right, another thing we can do is to actually proceed to just mess around with the concept of markers themselves, right? You guys know what we just did is called a scatter plot. Okay, scatter plots by default or by nature, they just consist of data points that are kind of depicted or shown on a canvas, and how this is done is by using markers. Okay, now, what we also have is the ability, in certain situations when we are working with line plots, for example, you may want to have some sort of indication, of every X amount of values or data points or so on. Okay, now this leads me to just demonstrate for you the next example that we can do. So, go ahead, import numpy as np, import matplotlib dot pyplot as plt. That's fine. Now it's the same procedure. Generate some dummy data. X is equals to numpy dot linspace. Let's do -6, 6, and 1024. Let's have our two plots. Y1 is equals to numpy dot sin c. Let's do x. Y2 is equals to numpy dot sin c. Let's do x plus 1. That's fine. Now it is time to plot these values, and as I mentioned, we are doing this now on a line graph. Okay, because let's face it, right, I told you guys previously that logically speaking, there's not much difference between a line plot and a scatter plot. It's just that in a line plot, we implicitly or explicitly assume that one point follows the other, and that's why we join it in the same manner. Okay, with keeping in mind that we assume that one point follows another, then we just join those dots. But the point is, even a line plot starts off as a scatter plot. Okay, so what we are doing now is, as you will see, I want to do plt.plot. Let's do x, y1 marker is equals to a string. Let's do a lowercase letter o. Color is equals to, let's do 0.75. Go ahead, copy this, and we will just change a few of the values here. So x, y2, we leave the marker the same. The color for this one, the second plot, we can make black. And this is another parameter you are introduced to. It's called mark every, and it basically denotes the number of points after which a mark should occur on the plot. So if I set this to a value of 32, for example, I will now call plt.show, and you will see what happens is that after every 32 points that have been plotted, we basically obtain, okay, so something here is not really working out right. What is it? Okay, and it is because of my data itself. So up here, guys, in the x value a creation, I said -6 and -6. It should be -6 and +6. Okay, so just make sure you correct that. Now, when I run this, as you are seeing, right, if you look at the gray colored gradient or distribution, what you'll notice is that there are several circular data points here, guys, and because of the fact that they are being plotted continuously one after the other, we are unable to actually recognize, individual data points. But now, if you look at the graph or gradient above, the first one, the black one, what you'll see and realize is that what's happening is that after every 32 data points that have been plotted, we are having a data point that is being marked. Okay, and that is what the mark every parameter actually does. So that is interesting for you guys to know. Now, another good one we can demonstrate here is called controlling the marker's size. So again, the marker simply refers to the point itself. Now we can control the size of the marker, so we can make them bigger or smaller. Okay, so let's do our importations again. Import matplotlib dot pyplot as plt. Let's do a is equals to numpy dot random dot standard normal. Within the standard normal parenthesis, pass a tuple of 100 by 2. Next, we'll do a plus equals to numpy dot array, and within another set of parentheses, we'll do -1 and -1. Do the exact same procedure, guys. Now we are setting up the data for B. If you would like, I should mention to you, you can just copy paste the data that we used in previous exercises, right? It will save you coding that you need to do. If you'd like to code along with me though, you can also proceed to do the same. So this is going to be a tuple in which we have 100 by 2, b plus equals to numpy dot array. Within this, let's pass 1 and +1, so two positive ones. Now plt dot scatter. Within this, let's do b. So it really does not matter the order in which you plot your visualizations. That is up to you. So let's do b all rows of column 0. Now we will do b all rows of column 1. Let's do c is equals to k. That's basically color. And now let's do s is equals to 100. Okay. Now, what's important to understand is the parameter that we use to affect the size of the marker is actually represented by S. That's the name of the parameter that we can use to affect or change the shape or the size rather of the marker. So you can set S to any value that you like. So let's plot the second one. Let's do A, and now we leave the color the same. You guys can leave the color the same, or let's be a bit fancy and make this blue. And the size, let's make this size 25. What you'll notice, right, is when we call plt.show, the black colored dots or markers are going to be larger than the blue colored dots or markers. So I do a control enter. Okay, so I forgot my parenthesis again. Don't forget the tuple, guys, in this line here. So control enter, and as you will see, the black dots are indeed larger. This is because of the size parameter that affects the size of the markers. So I hope that is interesting to you. Now, there is one more cool thing that I'd like to show you in this video. And you guys know, right? Sometimes like you may have some sort of epicenter, right, in the data set. So basically one dot or one data point in the data set can become the center point. And the further away other data points are from this center dot, the larger the marker size actually becomes. So let me actually demonstrate to you how you can achieve this kind of logic. So import numpy as np, import matplotlib.pyplot as plt. Next, what you want to do is set up m is equals to np.random.standard normal. Within this parenthesis, a tuple that is 100 by 2. Let's do r is equals to numpy dot sum. We'll do m multiplied by 2. Let's do axis is equals to 1. Again, guys, there's nothing much for you to pay attention to here because this is just us setting up the x and y values themselves, right? Nothing major. What's important that I want you to pay attention to is R. R is important. Think about it. We are summing M. M is an array multiplied by the power of, so M to the power 2 and axis is equals to 1. So that is the columnar axis. Okay, now what we will do is plt.scatter, we'll call m, we'll say all rows of column 0, m, all rows of column 1. For the color, let's set the color to be equals to, maybe I'm thinking maybe a yellow or something that stands out, maybe green. So that's fine. We'll set the color to green. We'll do marker is equals to s, and let's do s is equals to 32 multiplied by r. plt.scatter, or rather plt.show. And now, guys, this is the logic we achieve. Now, if you guys want want some sort of explanation, right, what I'd like to mention is that, you see, the ability to change the size of the markers, right? We know that we have the ability marker size. Marker size is what we can use to change, or basically S, that will change the size of the marker. Now, if you think about it, right, in our case, the size of the marker itself is really a list. It's a list slash array, because think about it, we are taking 32 and we are multiplying by the value in R. R is an array. If you look at R, if you view R, so I actually didn't run this, so let me run this, and now I view R. R is an array, so S is being propagated to an array of values, which is taking on the appropriate, data point depending on the distance from the epicenter, the data point that is considered the epicenter. So I hope this makes sense to you. Okay, it is super interesting stuff, guys. Now, for this video, I think we will end this here. There is nothing much more that I'd like to actually demonstrate for you. Actually, before we actually conclude this video here, maybe I would like to demonstrate just one more thing for you guys. It has to do with the concept of markers. It's basically us having complete control over, let's say, markers. Okay, I will end the video after this point here, guys. So this is where I'd like to just list very useful parameters that you can use when you are working with your plots, especially if you have markers that are involved. So go ahead, import numpy as np, import matplotlib.pyplot as plt. That's fine. We'll set up an x and a y for ourselves, so we have some dummy data to work with. I'll do x is equals to numpy.linspace -6, 6, 1024. Let's set y to be equals to numpy sine of x. Now, a simple line plot is what we are doing. I just like to list for you important parameters and arguments that you can use, so you guys know the x and the y are the most important ones. Now we have these styling parameters that we can use. We have line width is equals to, let's set this to a value of 3. We have color is equals to, let's set this to a value of k. we have a parameter called marker size is equals to, let's set that to a value of 9. We have marker edge, EDG, I spelled that right. So marker edge width is equals to, let's set this to a value of 1.5. There's another one called marker face color is equals to, let's set this to 0.75. Next we have, let's do marker edge color is equals to, let's make this blue. So these are going to be really funky looking dots that we have on our plot. Marker is equals to, this is going to set the shape of the marker. So let's keep it fancy. Let's do maybe an, oh, let's leave it as a standard dot, the round circular circle, so you know we can see what effects all the styling has. And last but not least, I would like to do mark every, and let's keep this as 32. So as you guys can see, right, our ability and the possibilities for styling your plot are, you know, endless. There's several combinations you can work with, guys. If we run this, as you see, we obtain a really, I would say this looks good. This visualization looks really neat and good to view. So that's what we have, guys. You can mess around with these parameters, and obviously I recommend that you look at documentation and other sources of information for yourself, because at the end of the day it is just going to give you much more exposure and experience, you know, with regards to styling and, you know, just messing around with the way your plots look. So aesthetics. So that's all for the styling portion of MatPlotLib, guys. I hope you found this section of the tutorial series interesting. Do make sure to leave a like for the video, subscribe to my channel for more tutorials, and yeah, the next aspects we will look at of MatPlotLib with regards to our visualizations is that of annotations. So we will tackle that in the next video onwards. So thanks guys, good luck with your work, and I will see you in the next YouTube video.